Okay, let's move down and talk about the quotient property. So if you'll notice on each of these problems, you have a fraction underneath a radical. And this is where you kind of start talking a little bit about rules, or maybe not even rules, but just kind of etiquette in math. And one of the things that you don't do in math is you aren't supposed to have a fraction under a radical symbol. So the first thing I would do on this problem is I would split this up. I'm going to kind of leave myself some space here. I would split this up so I have the square root of 25 over the square root of 16. So this took care of the issue of having a radical with a fraction under it. So now I'm going to work with each part. The square root of 25 is 5, and the square root of 16 is 4. So this problem's finished. Okay, let's look at the next problem. So same thing happens here. I end up getting a square root of 40 over the square root of 90. And so there are a lot of different shortcuts you can take on this problem. One thing I noticed is this thing is like having the square root of 4 times 10. And this is like having the square root of 9 times 10. So if I wanted to, I could split this apart and have square root of 4 over square root of 9 times square root of 10 over square root of 10. And these would cancel because I would have the same thing in the numerator and the denominator. And so my answer would just be the square root of 4, which is 2, over the square root of 9, which is 3. So without having to rewrite this, I could just notice, well, both of these have a 10 underneath the radical. So since they're both under the radical from the very beginning, I could have crossed off the 10s because anything over itself makes 1. So the answer to this is 2/3. Okay, let's look at the next one. That one, when I split it apart, I'm going to have square root 7 over square root 16. And it just so happens that 16 is a perfect square. So the square root of 16 is 4. The square root of 7 doesn't have a perfect square, so I'm going to leave it. A square root of 7 over square root of 4, or excuse me, over just 4. Now it looks like this. The hard thing about the radical problems is they seem easy while I'm working them, but they're all just a little bit different. So if you start a homework assignment and you feel like you're just not sure what's going on, come back and rewatch the videos or watch more videos on radicals. Okay, let's look at this one. So square root of 80 over square root of 45. So I'm going to look and see if I can get anything to cancel. I know this is going to be, and I'm going to write out beside just to save room. I know this is going to be square root of 80, which is 8 times 10. And this is square root of 45, that's 9 times 5. Well, I know that the square root of 9 is 3, so I'm going to go ahead and cancel that one and put a 3 there. So square root of 9 is 3. I also know that 10 is 2 times 5. And so when I have a square root of 5 on top and a square root of 5 on bottom, those can cancel. So let me rewrite what I have now. On the top, I have square root of 8 times 2. And on the bottom, I just have 3. I'm going to keep looking to see if that 8 times 2 will factor. And 8 will simplify to 4 times 2. So now I can move some stuff out of the radical. When I have 2 of the same number, that puts 1 of that number out here. And the square root of 4 is 2. So on top, I have 4, and on bottom I have 3. Notice there's no more square root in this problem. Everything that was under the square root came out of the square root on the top and the bottom. Okay, let's look at the last one on this row. So this negative just means like -1 times. So I'm just going to start factoring. So I'm going to have negative on top, and 18, I'm going to make 9 times 2 because 9 is a perfect square. So the square root of 9 is going to pull a 3 out to the front. Now, where we put that 3 is going to be right in front of the radical. So this is the way it should look. -3 and then the square root of 2, and on the bottom I have 3. But what I notice on this one is I have a 3 outside of the radical and a 3 outside of the radical. So those things are actually going to cancel out, because anytime you have the same number in the numerator and the denominator and you're multiplying, then those can be canceled. So my answer would just be negative square root 2.